Hello, and welcome to Some Assembly Required Emerging Synthetic Cannabinoids. My name is Holly Pierzynski. I am the manager of the Forensic Novel Psychoactive Substance Research Department within the Forensic Division at Cayman Chemical. Cayman Chemical is located in Ann Arbor, Michigan. We are an ISO-accredited analytical reference standard provider and have an extensive catalog of research standards. Our Forensic Division is a team of talented scientists dedicated to making research possible for our colleagues in forensics and toxicology. Cayman has several resources available at your disposal to help with identification, including our free Cayman Spectral Library, which is updated with new compounds quarterly. The latest update was early September, and an additional 69 compounds were added, giving a total of 2,516 spectra within the library. We also have our GC mass spec drug identification tool on our website to help with the identification of unknowns. If you can't find your unknown, you can submit your GC mass spec data, usually in PDF or JPEG forms, and any relevant information to our tech support department at techserve@caymanchem.com. My area of focus is identifying and researching new novel psychoactive substances. I have been the leader of our GC mass spec unknown program for the last 6 years, helping the forensic community identify new substances within their casework. Today, I will be discussing the latest emerging synthetic cannabinoids, their precursors, and why we are seeing them. After the class-wide ban on synthetic cannabinoids in China, we have now begun to see these do-it-yourself kits in which the compounds are semi-finished. They are providing the precursor, which is usually one step behind the finished product, which I'll show you on the next slide. This is for the end user to finish the synthesis themselves to get around regulations. Many of these do-it-yourself semi-finished kits are being offered on illicit direct-to-user sites, such as some examples I have here. They are being discussed on Reddit, Google Groups, and SoundCloud, which I have an example here, and they're even offering lab equipment to help the end user finish the synthesis. So now let's take a look at how some indazole synthetic cannabinoids are synthesized to understand why we are seeing these precursors within samples. And this is very generalized, keep in mind. So there are a couple different pathways. If you start off with route A, you can either purchase this indole or indazole carboxylic acid and react it with the appropriate amine, and in this case L-tert-leucine, to obtain this following precursor, which is one step behind the finished product. But if you follow route B, using the same indole or indazole carboxylic acid, you can react this with the appropriate tailpiece, which I have some examples here, to obtain this precursor, which is also one step behind the finished product. So route A will give you this headpiece precursor, route B will give you this tailpiece precursor, but both routes will lead you to the final product. All you have to do is either add the tailpiece to the route A precursor or the amine or headpiece to the route B precursor. I'm briefly going to go over some route B precursors because most of my talk will discuss the route A precursors. The route A precursors seem to be emerging a lot more. So to reiterate, the route B precursors have the tail in place, no head, and here are several tailpiece carboxylic acid precursors that you may encounter in your samples. Keep in mind, these can also be found as metabolites in toxicology samples, and why many of the names on our website have metabolite in the name. So now we will be focusing on the route A precursors. These are the precursors with the head in place and no tail, and we will be specifically looking at the indoles first. So here are some intermediates precursors that you may encounter in your samples. For instance, 1'-naphthoyl indole is a precursor to several synthetic cannabinoids such as the traditional JWH18. This 2,2-chlorophenyl 1,1H indole 3-olefenone is a precursor to JWH203 and was recently identified in do-it-yourself kits in the Russian Federation last year. 1H indole 3-il-2233 tetramethyl cyclopropylmethanone is a precursor to the traditional synthetic cannabinoids such as UR144 and XLR11. ADB-INACA is a precursor to ABD-fubiata, which emerged on the market in 2021. So now let's take a look and a deeper dive at MDMB-INACA. MDMB-INACA was identified in samples in the US in fall of 2023. This precursor was identified in samples containing MDMB-PICA, which makes sense because if you look at the synthesis, all you have to do is add on the tailpiece, in this case the bromopentyl chain, to get the finished product of MDMB-PICA. So both of these monographs were released by the CFSRE in November of 2023, and at Cayman we had seen GC mass spec unknowns of MDMB-PICA in August and October, mainly from the Pennsylvania area. Here is the EI mass spec of MDMB-INACA. You see the molecular ion fragment at 288. If this terp-butyl group is cleaved here, you will see this presumed fragment at 232. Here are some presumed fragments for 214, 200, 172. You'll see the indole acylium ion at 144, the indole ion at 116, and here are some presumed fragments for 89 and 57. But MDMB-INACA is not just a precursor to MDMB-PICA. Depending on the tailpiece used, this can lead to several other synthetic cannabinoids. For instance, if you add on a butyl tailpiece, you may obtain MDMB-BUTINACA. Or if you use a 4-fluorobutyl tailpiece, you can get 4-fluoro-MDMB-BUTINACA. And if you recall, 4-fluoro-MDMB-BUTINACA or BICA emerged in 2020, and the CFSRE released this monograph in July of 2020. So we already discussed MDMB-PICA, but here are several other examples of using MDMB-INACA as a precursor and adding different tailpieces to obtain the desired synthetic cannabinoid. This does not encompass all of the possibilities of what the precursor MDMB-INACA may lead to. There are even more possibilities. So continuing to look at more Route A precursors, now we are going to look at the indosols. So for instance, cumul-INACA is a precursor to the synthetic cannabinoid 5-fluorocumul-PINACA, which emerged on the market in 2020. So now I'd like to look more closely at ADB-5-bromo-INACA and MDMB-5-bromo-INACA. Both of these started to appear on the market in 2021 and 2022. And they are unique in that we had never seen a bromine in the 5 position in a synthetic cannabinoid before. So now I'm going to discuss these precursors more in depth. ADB-5-bromo-INACA was first reported by Response 2 Project in December of 2021. A report was released in January of 2022 by what is now UDA, but used to be the EMCDDA, following a detection in an off-white powder in Hungary and in bladders in Turkey. The following drug testing and analysis paper does an excellent job of detailing all of the following detections that I'm mentioning from seed samples. This paper discusses how ADB-5-bromo-INACA was detected in seed samples in Scottish prisons and from Belgium customs in late 2021, and how ADB-5-bromo-INACA was seized in e-cigarette liquids in South Korea, but a time frame was not mentioned. According to this paper, ADB-5-bromo-INACA emerged in the US in Q1 of 2022, and the CFSRE released their monograph in May of 2022. But at Cayman, we are seeing GC mass spec unknowns come in from Pennsylvania, New Jersey, Indiana, Texas, and Turkey towards the end of 2021 and into Q1 of 2022. Here is the EI mass spec of ADB-5-bromo-INACA. You see a very tiny molecular ion fragment at 352, 354. You see the very distinct 1-to-1 bromine isotope pattern. And if this amide group is cleaved off, you will see this presumed fragment at 308, 310. Here is a possible fragment for 279, 281. You see the 5-bromo indosol acylium ion at 223, 225. Here's the 5-bromo indosol cation at 198, 196, 198. And here are some other presumed fragments for 168, 170, 116, and 86. So now we are going to discuss MDMB-5-bromo-NACA for a minute, and then we will revisit ADB-5-bromo-NACA again. So according to that same drug testing and analysis paper that I had mentioned before, MDMB-5-bromo-NACA was first reported by the EMCDDA in April of 2022 following detection of beige powder seized in Switzerland. It was often detected as a mixture with ADB-5-bromo-NACA, especially from samples in Scottish prisons and from Belgium customs in late 2021. This paper also mentions that MDMB-5-bromo-NACA was detected in New Zealand in August of 2022. The CFSRE released their monograph in May of 2022, and at Cayman we were seeing GC mass spec unknowns from Illinois, Florida, Texas, Pennsylvania, Ohio, Turkey, and the Republic of Mauritius all throughout 2022 and even into 2023. So here's the EI mass spec of MDMB-5-bromo-NACA. Again, you see a very tiny molecular ion peak at 367, 369. You see that very distinct 1-to-1 bromine isotope pattern. If this tert-butyl group is cleaved off, you see this presumed fragment at 311, 313. And if that ester group here is cleaved off, you see this fragment at 308, 310, which is very small here. And the rest of the EI mass spec is very similar to ADB-5-bromo-NACA. The most distinct difference is this 311, 313 fragment. So coming back to ADB-5-bromo-NACA, this precursor paved the way for other ADB-5-bromo synthetic cannabinoids, such as ADB-5'-bromo-BUTINACA, ADB-5'-bromo-PINACA, ADB-5'-bromo-4-ene-PINACA, 5-fluoro-ADB-5'-bromo-PINACA, and ADB-5'-bromo-DECANACA. We have seen possible GC mass spec unknowns of 5-fluoro-ADB-5'-bromo-PINACA from Arizona and ADB-5'-bromo-DECANACA from Arkansas. But now I'd like to focus on ADB-5'-bromo-BUTINACA and ADB-5'-bromo-PINACA. ADB-5'-bromo-BUTINACA was first reported by the EMCDDA in June of 2022 following a seizure in Hungary. It was detected between May and June 2022 in U.S. forensic casework, and the CFSRE released their monograph in May of 2022. At Cayman, we saw unknowns mostly from the Pennsylvania area in 2022, and this was also detected between October and December 2022 in Scottish prisons, according to this drug testing and analysis paper. Here is the EI mass spec of ADB-5'-bromo-BUTINACA. You see a very tiny molecular ion fragment at 408, 410. You see that very distinct 1-to-1 bromine isotope pattern, and if the my group is cleaved off here, you see this presumed fragment for 364, 366. Here's a possible fragment for 335, 337. You see the 5-bromo-butyl indazole acylium ion at 279, 281. And you see the 5-bromo indazole acylium ion at 223, 225. And here are several other presumed fragments for 209, 211, 116, and 57. So now looking at ADB-5'-bromo-PINACA, according to this drug testing and analysis paper, which just came out this year, ADB-5'-bromo-PINACA was first reported by the EMCDDA in August of 2022. The Public Health Agency of Sweden also released a report in October of 2022 following a seizure in Portugal. This was detected in the US in 2023, and the CFSRA released their monograph in May of 2023. And at Cayman, we are seeing this synthetic cannabinoid not only emerge for sale on direct-to-user sites, which I have an example here, and which they were calling 5-bromo ADB-BUTINACA, but we had also seen some unknowns come in 2023 from France. So here's the EI mass spec of ADB-5'-bromo-PINACA. Again, you see a very tiny molecular ion fragment at 422, 424. You see that very distinct 1-to-1 bromine isotope pattern. If the my group is cleaved off here, you see this presumed fragment at 378, 380. Here's a presumed fragment for 349, 351. You see the 5-bromo pentyl indazole psyllium ion at 293, 295. You're seeing that 5-bromo indazole psyllium ion again at 223, 225. And here are some other presumed fragments for 209, 211, 116, and 57. So coming back to this slide, now we will be focusing on another indazole precursor, specifically ADB-INACA. ADB-INACA was first reported by the EMCDDA in August of 2022. It emerged in the US in April of 2023, and the CFSRA released their monograph in June of 2023. Here is the EI mass spec of ADB-INACA. Again, you see a very tiny molecular ion fragment at 289. If this terp-butyl group is cleaved off here, you will see this presumed fragment at 233. Here is a presumed fragment for 201. You'll see the indazole psyllium ion at 145, the indazole ion at 118, and here are some presumed fragments for 90 and 57. ADB-INACA appeared in samples alongside ADB-4'-PINACA and ADB-BUTINACA. But in reality, ADB-INACA can be used to synthesize all of these synthetic cannabinoids. And these are just examples we have in our catalog. This does not include all of the possibilities. So for instance, you can use ADB-INACA as the precursor, and if you add the 4-fluoro-butyl tailpiece, you'll obtain 4-fluoro-ADB-BUTINACA. If you add the 5-fluoropentyl tailpiece, you will obtain the 5-fluoro-ADB-PINACA or 5-fluoro-ADB, and so on. So ADB-INACA, if not reacted all the way in the synthesis, has the potential to show up in samples of the desired finished product and all of these possibilities. So coming back to this slide again, now we are going to focus on another recent precursor, ADB-5-methyl-INACA, which is unique because we have not seen a synthetic cannabinoid with a methyl group in the 5 position until now. ADB-5-methyl-INACA emerged on the market in November of last year. This is what the EI mass spec looks like of this precursor. You see the molecular ion fragment at 303. If this terp-butyl group is cleaved off, you'll see this presumed fragment at 247. Here's a presumed fragment for 215. You'll see the 5-methyl indazole psyllium ion at 159, the 5-methyl indazole ion at 132, and here are some other presumed fragments for 104, 77, and 57. But as of yet, we have not seen any synthetic cannabinoid with a tailpiece that has incorporated this precursor, so keep an eye out for this precursor and any related synthetic cannabinoids. So coming back to this slide again, now we're going to discuss this following precursor, ADB-INACA. ADB-INACA was first detected in the United States in November of 2022. It is a precursor to several different synthetic cannabinoids. I have 11 here on this slide, which is just the ones that we have in our catalog. So again, there could be several more possibilities. Several of these synthetic cannabinoids are controlled substances, including ADB-BUTINACA, ADB-PINACA, ADB-4'-PINACA, ADB-FUBINACA, and ADB-CHIMINACA or MAB-CHIMINACA. So if the precursor doesn't react all the way and there's excess, you may encounter a challenge of the two compounds co-eluting together. This is especially a challenge when one of the compounds is a controlled substance, such as the 5 that I have highlighted here. So next we will look at when ADB-INACA does in fact co-elute with one of these controlled substances. So starting in late 2022, we started to receive requests for help with identifying a new synthetic cannabinoid with the following EIMA spec. And we had several unknowns come in from Texas, Arkansas, Pennsylvania, Kentucky, Illinois, and Turkey. When analyzing the mass spec, we noticed several similarities with first ADB-BUTINACA. For instance, the fragments that I'm about to highlight, 286, 257, 201, 145, and 131. But then we noticed several similarities with ADB-INACA, its precursor as well, such as 230, 201, 162, 145, 118, and this 8690 pattern. So we concluded that the possibility was a coelution of ADB-INACA with ADB-BUTINACA. And due to the number and frequency of unknown requests, and on top of that, several requests on methods to help differentiate them, our ISO department developed a method on how to separate these two compounds. The following application note, GC separation of ADB-BUTINACA from its precursor ADB-INACA, was just released in September of this year, and the following QR code will take you right to the application note. So first we replicated the coelution between ADB-BUTINACA and ADB-INACA using the following parameters. Our instrument is an Agilent 8890 GC equipped with a 5977B mass spec detector. The injector temperature was 300 degrees Celsius. The oven temperature method started at 50 degrees Celsius, hold for 1 minute, increase at a rate of 30 degrees Celsius per minute up to 300 degrees Celsius. The total runtime was 15 minutes. The injector mode was a 15-to-1 split, and the carrier gas was helium at a constant flow rate of 2 milliliters per minute. This was done on a DB5MS column, which is equivalent to a 5% phenyl methyl polysilicon USP grade G27 column, which you can see here in figure 2. So after several attempts to resolve the peaks by adjusting the oven temperature and using this column, the mixture of both components was then injected onto the instrument using a DB35 MS column, which is equivalent to a 35% phenyl methyl polysilicon USP grade G42 column with mid-polarity. This resulted in baseline separation of the two components with a peak resolution greater than 1.5, which you can see here in figure 3. So if you'd like to learn more about this, you can check out our application note on our website or using this QR code. So now I'm going to switch and discuss some possible byproducts you may be seeing within your samples and why we are seeing them. So in 2022, we had several GC mass spec unknowns start to come in with the following EI mass spec. And then the compound 4-ene PDMB4-ene-PINACA was reported on absent as well as by the EMCDDA in seized material in 2022. So this is a bis-alkylated synthetic cannabinoid where the tail piece is also located on this ester top chain. And looking at the EI mass spec, you see the molecular ion at 411. When this tert-butyl group is cleaved off, you see this presumed fragment at 355. When this whole ester group is cleaved off, you see this presumed fragment at 298. You see the indazole psyllium ion with the 4-ene pentyl piece at 213. And then you see some breakdown of the alkyl chain at 41 and 67. And then similar to the previous slide, this year another bis-alkylated product is showing up in casework, tentatively named 5-fluoro-PDMB5-fluoropinaca. So again, the molecular ion is 451 of this, which was cut off. But if you cleave that tert-butyl group, piece, you'll see this presumed fragment at 395. And when the whole ester group is cleaved off, you'll see this presumed fragment at 318. And then that 5-fluoropentyl indazole acylium ion at 233. So here's another bisulculated compound to keep an eye out for in your casework. So why are we seeing these? Well, let's take a look at the synthesis. So if you start off with the precursor ADB-INACA, usually some sort of base is used to put on these tail pieces. And if the base is strong enough, you may get hydrolysis of the methyl ester as well to the acid, and this could be a reason why the tail piece is adding not only to the indazole nitrogen, but to the acid group as well, resulting in these bisulculated byproducts. So that is just a possible reason of why we are seeing these. So now we're going to take a look at some new synthetic cannabinoids to keep a lookout for. 3-TMS ADB-BUTINACA was identified in Germany, seized by Bavarian State Police in November of 2022, and 3-TMS cumulpurnaca was identified in plant materials seized by Swedish Customs in March of 2023 and was found in smoking herbal mixtures called the Joker. So keep an eye out for these. Cayman is releasing these new synthetic cannabinoid analytical standard panels. These contain small quantities of synthetic cannabinoids, metabolites, and precursors in individual tubes to aid in library development. So panel 1 is available now, and it includes the early generation syncans from the early 2000s to 2012. Panel 2 is coming soon, and this will span synthetic cannabinoids from 2012 to 2017, and then panel 3 will span synthetic cannabinoids from 2017 to through the end of this year through 2024. So this will be coming out towards the end of this year or early next year. In conclusion, synthetic precursors are being sold online that are one step from final synthetic cannabinoid products. We are also seeing this with benzodiazepines. The synthetic precursor being trafficked are common to many synthetic cannabinoids, and new analogs will continue to emerge. The proliferation of these do-it-yourself kits are resulting in mixtures that can complicate forensic analysis with overlapping GC peaks. And synthetic precursors can share the same characteristic EI mass spec base peaks, leading to potential misidentification. Thank you for listening today. Here's the QR code again to access the application note, and if you would like to receive email notification on new MPS standards, new tools, and new publications, you can register at the link below, and also follow us on LinkedIn, Facebook, and X.